All right, so the last example we're going to do that involves average value is an application problem. In this problem, it says that the marginal cost function for Reed's Cookie Shop is given by C prime of x equals 0.1x plus $5 per cookie when x cookies are made. We have two parts to this problem. We want to find and interpret. So we're gonna work it out, and then I'm just going to talk through the interpretation. For part A, we want to find the average marginal cost when the number of cookies made is between 10 and 20. So we have a marginal cost function. That means we already know the function that we want to use for this problem. It's this, C prime of x. And it says when the number of cookies made is between 10 and 20. This is giving us our interval that we want to use. So for part A, we have 1 over the difference between the upper and lower limits, 20 minus 10, times the integral from 10 to 20 of this function right here, 0.1x plus 5 dx. Okay, so now we integrate. This is just 20 minus 10, which is 10. I get 1/10. Here, I'm going to get 1/2 times 0.1, which is 0.05 x squared plus 5x, and again from 10 to 20. Okay, this is the interval that we're using. This is going to equal 1/10 times 0.05 times 20 squared plus 5 times 20 minus 0.05 times 10 squared plus 5 times 10. Okay, now I'm going to see if I can work this through with some mental math techniques. So I know I'm going to take these two terms right here because they have the same coefficient, 0.05. If I treat that 0.05 like an x and I square 20, that's 400, then this would be like 400x. This minus will distribute here. 10 squared is 100, so this would be like 100x. 400x minus 100x is 300x. But remember, it's not actually an x. It's 0.05. Okay? So we'll deal with that in a second. And then here, this minus will distribute. I have 5 times 20 minus 5 times 10. If I think of that as 20x and 10x, subtracting those would give me 10x. That's 10 times 5. So we're just going to kind of take different, mental math tricks here to sort of make things easier. Now, if I multiply this 1/10 in, it's going to turn that 300 into a 30. So I have 30 times 0.05. 5 times 10 is 50, but dividing that by 10, I would get plus 5. And then here, multiplying by a multiple of 10 is going to move this decimal place over 1 time, so it becomes 0.5. Then I multiply that by 3, which would become 1.5 plus 5, that's 6.5. However, this what does this represent? It's an average marginal cost. So being a cost, it's measured in dollars and cents. I'm going to add a 0 there because I wouldn't normally see this written as $6.5. I would see it written as $6.50. Okay, so what this is telling me is that, remember, when we do marginal analysis, we can interpret marginal cost as the rate of increase in our cost when a certain amount of cookies are sold. And because this is an average, then what this is saying is that when we sell somewhere between 10 and 20 cookies, the average increase in cost per cookie made is an average rate of $6.50 per cookie. That's the first one. That's part A. Let's look at part B. Part B says find the average cost when the number of cookies made is between 15 and 40 if we know the cost of making 50 cookies is $1,350. This is similar to a problem we saw in the previous section where you want the average cost of the original function, not the derivative. Okay, so the average cost function, we're looking for c of x. We don't have c of x, we have c prime. But c of x would be an antiderivative of c prime. So I just need to take an antiderivative of that, 0.1x plus 5 dx. We technically already did that here. It's the stuff in the square brackets, 0.05x squared plus 5x, but then it's an indefinite integral, so we have plus c. Just like the example in the previous video, we find this value of c using the additional information that's given to us. So it says that if we know that the cost of making 50 cookies is $1,350, then we can use that to find c. So $1,350, that's the value of c that we're going to use here, 1,350. And then we set that equal to 0.05. We're plugging a 50 in for x, so that becomes 50 squared plus 5 times 50 plus c. Okay, 50 squared is equal to 2,500, so this becomes 0.05 times 2,500 plus, this is equal to 250 right here, plus c. I have 2 zeros at the end of this number, which is going to bump this decimal over 2 spots, and then I multiply that by 25. So 5 times 25 is 125. 125 plus 250, let's make sure I got that right, 125 plus that is going to be 375 plus c. And so if 1,350 is equal to each of these, I could subtract 375 from both sides to get that c is equal to 975. Okay, that goes back up here, and now I have c of x. So c of x is equal to 0.05x squared plus 5x plus 975. Now we have what we need. So going back to what the problem was asking for, what is the average cost when the number of cookies made is between 15 and 40? We have a cost function, and the interval would be the interval 15 to 40. So now I can find my average cost. 1 over 40 minus 15 times the integral from 15 to 40 of the function we just found, 0.05x squared plus 5x plus 975 dx. Okay, 40 minus 15 is 25, so this becomes 1 over 25. Integrating this is not too bad, so we're going to multiply or add 1 to the exponent, divide by 3, 0.05 over 3 times x cubed plus, this would become 5 halves, x squared plus 975 x, and this is evaluated from 15 to 40. Okay, doing the arithmetic now, I'm going to get 1/25 times 0.05 thirds times 40 cubed plus 5 halves times 40 squared plus 975 times 40 minus, don't forget to put this in parentheses, 0.05 over 3 times 15 cubed plus 5 halves times 15 squared plus 975 times 15 parentheses square bracket. All right, that is a lot. Even with mental math or, shortcuts, it's still a lot. So for this one, I'm going to just jump to the answer. You can plug it into a calculator if you want to do it that way. This should work out to, again, it's a dollar amount, $1,152.92. That would be the average cost of the number of cookies made between 15 and 40. Okay, that's it for 4.5.